Welcome to my talk to this year's EnergyInformatics.Academy. We have 2023. My name is Thomas Bleistein. I'm from the August Wilhelm Scheer Institute in Germany, and I have the great honor to present our work out of the research project EI.A, founded by the German government in cooperation with the Hochschule Worms. The topic is the power consumption analysis as a detection indicator for cyber attacks on smart home devices. So what is the project mainly about? The project is about cybersecurity and smart homes. And we have the work package that we want to get the power consumption analysis for IoT devices as an additional layer for the security in smart homes. And therefore, we want to detect anomalies in the power consumption patterns by collecting the data. But why is it so important to care about IoT devices in smart homes? Statistically, in Germany, every household has more than one IoT device already. By a decreasing cost and the benefits we gain out of the IoT devices, the number will increase over the next years, and we have a lot more IoT devices in households. At the same time, IoT devices capture and transmit sensitive data, which is not that good when the cybersecurity is not so high as it is for IoT devices, which are quite vulnerable for cyber attacks. This leads to three major issues. The first is we have a loss of privacy for households. The second one is that we could gain damage out of to the property of households. And related to this, we have a third issue, which is it could cause physical harm due to malfunction and to fires from IoT devices. And therefore, we had a research aim in this study where we want to research on the impact of cyber attacks on the power consumption of IoT devices by identifying patterns and anomalies in the power consumption data. And with this, we want to get the potential and the limitation of using the power consumption as an additional layer to detect cyber attacks on IoT devices. How did we proceed inside the study? So we made a hardware testbed with 10 different IoT devices from different companies. We simulated cyber attacks. We focused on one special cyber attack, but in the future there could be more. And in the third step, we used sensor to measure the power consumption of each of the IoT devices. How was this done? We made 1 month of collecting the power consumption data. Why did we do it over such a long period? We wanted to avoid that we have false data indicators and want to have data also when there is an update from our IoT devices. Inside this month, we also made the simulation of cyber attacks. So we made real cyber attacks on the IoT devices. And then we used the collected data to make data analysis and to see if we find any patterns regarding or related to the cyber attacks. For the testbed, I mentioned we had 10 different devices. The devices we got into different groups after we measured the power consumption. The groups are here given as 1, 2, 3, and 4. In group 1, there are mainly the smart home hubs. In group 2, we find sensors and actors for IoT devices. Group 3 only consists of one normal office device, like a Canon printer in this case. And in group 4 are also devices out of group 2, which means that group 4 is just a subgroup out of our group 2, which we will see later why it is selected like this. For all of the sensors, we made plots 30 minutes before the attack, during the attack, and 30 minutes after the attack. And we saw the change in the power consumption during the attack. For group 1, we selected an Amazon Alexa as a representer. And we saw a clear upward change during the attacks of the power consumption, which indicates that we have a noticeable impact on the power consumption. And with monitoring the power data, we have an additional layer to identify early the cyber attacks. Group 2, we used as a representative the Google Nest, but there are also other sensors and actors inside of it. What we can see, we have a different behavior during the cyber attacks from the power consumption. So we have small intermittent spikes as well upwards as downwards, which makes it a little bit more complicated to identify the cyber attacks. But this power consumption patterns could also be used to detect the attacks. But we need advanced statistical analysis and or machine learning algorithms. The third group only consists of an office device, in this case a printer. What we can obtain out of this diagram is that we have occasional upward spikes during the attacks, but we don't have downward spikes. And for all the first three groups, we have come back to the normal level of power consumption right after the attack. So for group 3, it means that we could use the power consumption as an indicator, but to make it reliable, it is quite hard. So final result could be that we provide it as an indicator, but combine it with other detection modes. As I mentioned, group 4 is just a subgroup out of group 2, mainly consists of the Netamo devices, and we used as a representative the thermostat of Netamo. And what we can see here is, in addition to the intermittent spikes upwards and downwards, a significant increase in the power consumption right after the cyber attack. What does it mean? So we have also the possibility that after cyber attacks, the energy consumption of IoT devices could last longer than when we thought. And with this, we have a less good energy efficiency. So it states also the importance of detecting cyber attacks quite early to also avoid a higher energy consumption right after the cyber attacks or a damage to the IoT devices. To sum up all the results, we have for all the devices an increase in the power consumption during the cyber attack. For group 1, up to 50% of an increase. For group 2 and group 3, we have about 20% of increase in the power consumption. And for group 4, there's about 50% increase in the power consumption. What we have in addition is that we have for group 4 post-attack power consumption, so we don't fall back directly to the pre-attack power consumption levels, which is quite interesting because then we have also a dysfunction after the cyber attacks, and it could lead to a failure of the IoT devices. What we also obtain out of it is that group 2 and group 3 have mixed patterns, and they could return to pre-attack level, but also the possibility that they don't. What we found out as limitations for our study is, first of all, insufficient data. So we have a relatively small sample device size, which means that our robustness for the conclusion is limited in this paper. What we also obtain is that we have potential biases. We only used one hardware test bed, so it could be that we have an offset inside our study related to the one test bed or the one network we used. And the first and last limitation we can state here is that we only use one kind of cyber attack. And the cyber attacks are also simulated, so we don't have a real scenario where we made cyber attacks on real households. So what is a possible future work which we can use to increase our study? So first of all, we could improve the device diversity by adding different sensors and different IoT devices from different companies inside such test beds. And what we could do in addition is to use also devices that use battery. With this first improvement, we could get definitely claim about the relationship between cyber attacks and the power consumption on the other side from the IoT devices. A second improvement would be to go into live scenarios and to use different cyber attacks. This would fully reflect the real world scenarios and would prove our concept for the real world. It would be also quite complicated because it's not very easy to make cyber attacks on live scenarios and on real households. And one additional thing which goes more into the physical stuff is that we identify the cause of different device group formation. So what is the cause on the hardware side that some sensors have post-attack power consumption increase and some doesn't? To conclude this talk, we can add an additional level of cyber attack defense by monitoring the power consumption and analyzing the patterns. We build the base for taking appropriate countermeasures, and it might be a supplement to existing security measures in smart homes. To sum this all up, we have a significant implication for improving smart home security by using energy consumption data from the IoT devices. So with this, I want to thank you for your time watching this video, and if you have any questions, feel free to contact me. My name is Thomas Bleistein, and you can contact me by phone or by mail.